Okay, I am going to talk about factoring quadratics today. The uh, the first thing I'm going to do though is give you a little cheat sheet when it comes to the signs and stuff like that. Um, well, I'm going to do that while doing this problem. So I'm going to do this slightly different than the way that the book does it. If if you understand the way the book does it, you're going to say, "Oh, they're very, very, very similar," because they are. Pretty much the only difference is organization. So in this case, I'm going to go. I need two numbers that multiply to a positive 12 and add to a negative 7. So I'm going to write 12 down over here. And I'm going to write down everything that multiplies to 12. And the big one that people forget is 1 times 12. So then 2 times 6, and then 3 times 4, and well, that's it. But I need them to add up to a negative 7. And this is where people get a little confused with the signs and everything else. So I'm just going to give you a little cheat sheet here. So if both numbers here are positive, and by here I mean both signs here and here. These are the two signs that I'm going to be talking about. So if it's positive, positive, then both are going to be positive. Okay? So that means that both of the factors are going to end up being positive. If this is positive, negative, that means that we're looking for something that multiplies to a negative number and adds up to a positive number. That means that the big number is the positive one. Or you could say the little number is the negative one. If you end up with a negative, okay, in this case, that means that the little number is positive. And the last one is a negative positive, and that means that they're both going to be negative. So, and like I said, with each one of these, you could say, okay, this means that the little is negative, or that the big is negative here, that kind of thing. So you could add those in there if you wanted to. So there's your little cheat sheet. So we look up here, and we've got a negative, positive for the problem. So we look over here at negative, positive. Oh, that means that both numbers are going to be negative. So I'm going to come over here and make both of my numbers negative. Negative and negative on both sides. Now, which one of these adds up to a negative 7? Well, this one does. All we have to do to finish the problem is put down some parentheses, put an X at the beginning of each one, and then write those two numbers in there. Negative 3, negative 4. And that's it as far as factoring this. All right. So let's take a look at one more like this. How about x squared plus 3x minus 10? and we want to factor this one. So again, I'm going to come over here and I'm going to go, all right, I've got a 10, technically a negative 10, but we'll get to that in a moment. So 1 and 10, 2 and 5. Using our little cheat sheet, go back to it really fast. We got a positive, negative. So it says the big number is positive. So we'll come back here. The big number is positive. So the little number is negative. So which one of these gives me a positive 3? Well, this one does. So I put an X at the beginning of both of them, and then I write down the two numbers, negative 2 and a positive 5. Now, does it really matter which one I write down first? No, not at all. So I could have written down X plus 5 and X minus 2, and it would have been just fine. So this is the basics to factoring all the regular quadratics when the coefficient in front of the x squared, in other words, the number in front of the x squared, is a 1. But what about when the number is not a 1, like this one here? So if we have a situation where the number is not a 1, we just have to make a couple little changes to this. And normally this is actually a kind of a bigger deal, but it's actually not in our case here. The method that I'm going to show you here is called the Australian method, or at least one of the versions of the Australian method. So the first thing we're going to do is we're just going to take the a value and the c value. In other words, the number in front of the x squared and the number that's all by itself, we're going to multiply them. And that's going to equal 210. And then that's going to be the number that we're going to factor. So I'm going to factor this out. 1 and 2, 10, 2 and 105. Let's see, 3 and 70. 4 doesn't go in. 5 and 42. 5 and 42. And I can use a calculator here if I'm not sure. I can just go, okay, 210 divided by 6, 210, which 210 divided by 6. Let's see, that goes in 3, 5. So 6 and 35. 7 and 30. 8. I don't think so. 9, don't think so. Anyway, so I'm just going to stop right there for now. Now, we can look at our little cheat sheet. It says positive, positive. Both numbers are going to be positive. We're looking to try to make it add to a positive 37. Well, this one should be pretty easy. There it is right there. So I'm going to do just like I did before. And I'm going to go x plus 7, x plus 30. But because our coefficient is not a 1, in other words, the number in front of the x squared is not a 1, we have one more step to do. We're going to take this number, this coefficient, and I'm going to divide by 5 here. I'm going to divide by 5 here. Now, I can't reduce this at all. 7/5. Can't reduce it, so I'm just going to move the 5 right up into there. And I get 5x plus 7. On this one, oh, I can reduce 30 divided by 5 is just 6, so x plus 6. And I'm done. I'm done with that one. Now, if we wanted to make sure that we were correct, then we could actually just multiply now. We could take this and multiply it here and here and here. And we'd better be going back to our original problem. If we do, we know we got the factoring right. If we don't, then we know we messed up somewhere. Now, we're actually going to end up doing a number of these problems in class, and I'm actually going to end up showing you this same method in class. I just wanted you to make sure that you had this on video so that you could go back and watch it as many times as you would like. All right? Okay, we'll see you in class.